Okay, what is his USN?
29, I guess.
0 to 7.
0 to 7.
0 to 27.
027.
Okay, okay, I have marked him present.
Okay.
After that, you have just intimate him to call me up.
Sure, sir.
Okay, okay. Yes, I was discussing about the system and the control volume. Okay. Now, shall I give an example for this? I will illustrate the whole thing with an example now. Okay. I was talking about the venturimeter in the last class, is it? So venturimeter is used to measure the flow in a pipe. Okay. We will not go in depth how a venturimeter works, but we are very much interested to understand what exactly you mean by system and what exactly you mean by control volume. Okay. So system is the whole setup. So you'll be having a YouTube manometer connected to it in this way, and the resistance of head is also measured. And this might be connected to any other means like this. It might be connected to any other means. The whole of this thing is a system. Got it? So where you are actually analyzing the case of steady, the whole of this thing is called a system. Now, what is a control volume? So control volume is that particular region of space in a system, predominantly in the system. So where actually you are concentrating the thermodynamic study. So there has to be some region of space, in order to study the things. You cannot study the whole thing in whole of the system, is it? So I am very much concentrated what happens in this particular region of my space. Got the point? So I'm just highlighting the things up now. So this highlighted region of space is my area of concentration of study, which can be termed as, and which is termed as, your control volume. So control volume is a part of a system, or it is a region of space within the system where exactly you're concentrating your studies. Okay? So that is your control volume. Hope you got this.
Yes, sir.
Okay. So take the notes for the control volume. Hope you have taken this already, correct?
No, sir. We have to take.
Okay, just take
No,
the
sir.
notes
Control
for
volume.
the. Okay, so control volume and control surface, you just take the notes of it. Please do not join by any other means except the link which is sent to you in the mail, because I must keep looking into my laptop and just check, then admit them. Okay, so I lose that concentration, so do not do that. So that is your concept of control volume, and control surface is nothing but the surface which covers your control volume. Okay, that is your control surface. So as indicated with these examples here, okay, so controls volume may be real or imaginary, as the example I have just discussed. So here there is no actual surfaces. The actual surfaces only lies in this particular region here. So this is the only actual surface, the real surface. Okay, and these two surfaces, like this one and this one, are not real, but we are assuming it as a surface there. So the surfaces might be real or original, real or virtual, or the surfaces might be moving or stationary. So you can fix a particular region of space where you wanted to study the data, or you might change the surfaces predominant with the time. Okay, that is also possible. So when you change the surfaces with the time as its constraint, then you may get two different aspects of it. Number one being your moving boundary layer, and other being your fixed boundary. Okay. So just intimate me when it is done. So you are very much lagging. Have last two of your classes. So just make sure you make it fast. Okay.
Done, sir.
Sir?
Yes. Yes, Ashwita.
Sir? Excuse me, sir? Was tried to join in it since, but he couldn't join in. It got denied.
I denied
I'm not
him.
sure how.
I denied him.
He got the link.
He got the link, then you should not ask even the permission
Got
for
the
me
link.
also. He must join away straight away. Ask him to go to his Gmail.
I think
Ask
he's
him to go to his Gmail and go to his inbox in the mail sent by me. Okay. There he'll be having a joining link in the between. So if you click that, there is no requirement of the permission of acceptance. Okay, you can join straight away. Yeah.
Thank you, sir.
Shall we move?
Yes.
Yes, sir.
Okay. So next, there is a very important concept of types of properties. Okay. So there are two categories of properties. Of all the thermodynamic properties you want to study, there are two categories. The number one is intensive and number two is extensive. Okay. So what is this intensive and extensive are really? So intensive are those parameters. See, how do you remember this? I have a clue. So IN, that means it is independent of mass. Okay. Extensive being opposite of it, it is dependent on mass. Okay. So with this, you can remember this straight away. So intensive is nothing but a property which is independent of its mass. So if I vary the mass, that particular property will never change. Okay. It is totally independent of the mass content. The second property being extensive, which is totally dependent on mass. For example, can you just say me a few of the examples just by understanding the concepts of intensive and extensive? I will give you the few of the examples for an instant now. Okay. So initially, energy. You take an energy. So energy definitely depends upon the mass of the system, is it? So if the mass varies, if the mass content varies, definitely the energy will vary. So then energy is an example for an extensive property. Second property, density. Okay, when you go for density, which is represented by rho, it is straight away given as mass divided by volume. So it is totally dependent on mass here. So density is also an extensive property. Okay, like for any other properties you just want to categorize into intensive and extensive from your side. What about pressure?
So volume.
Okay, how do you, what do you categorize volume into? So volume is what? Intensive or extensive?
Intensive.
Huh? Yes, volume is?
Intensive, sir.
Why it is intensive? It is not dependent on mass.
No, sir.
Okay, so taking this particular equation here, I can just reshuffle it as volume is equal to mass divided by density. Now what's your statement?
It is dependent, sir.
So that's what. So volume is also
Right.
dependent on extension. Okay, so volume is also an extensive property. Now what about pressure? Pressure, guys. Even the
Depends on particular point, sir.
temperature. Even the temperature. So pressure can be defined as force acted per unit area, is it? Okay. So it is more often related to area rather than the mass of it. It is never been conveyed what kind of material are you using, yes or no? So definitely the pressure also will be of intensive in nature because it is totally independent of its mass. Whereas the temperature, whether it is dependent on mass, no. So temperature is also an intensive parameter where it is totally independent of the mass. Okay, mass content of the body. So there are three major properties to be studied in a thermodynamic cycle. Okay, those are PVTs. So naturally we call them as PVTs. So what are PVTs? PVTs are nothing but pressure, volume and temperature. So out of pressure, volume and temperature, the only parameter which is extensive is which one?
Volume.
Volume. So volume is the extensive parameter. Other two, that is your pressure as well as the temperature, will be intensive in nature. Hope this is clear for you. Okay, intensive and extensive. Shall we move further?
Yes, sir.
Okay.
Yes.
Next, there are some properties which are known as specific properties. Okay. Have you heard of any specific properties before? Like I would say specific heat. Okay, these are two types, specific heat at constant pressure, okay, and even there is specific heat at constant volume. Okay, and they are indicated by Cp and Cv. How many of you know this? How many of you have heard of this?
Constant pressure and constant volume.
Yes, so specific heats at constant pressure and constant volume. Can anyone say what is a specific heat at constant pressure and what is specific heat at constant volume? Okay, so here is an assignment for you, which has to be done with every individual in this session. So assignment is, you must know what is Cv and what is Cp, both the things. What exactly the specific heat is, okay, by any of the means and any of the sources you have. After that, I want the values of Cp, Cv, R and gamma for air as well as for water. Okay. Movie of screenshot. Okay. So Cp and Cv I have just told you it is a specific heat at constant pressure and a specific heat at constant volume. Now how do you get R? R is nothing but your universal gas constant. Okay. Hope you have heard in somewhere in second PUs. Okay. R is nothing but it is Cp minus of Cv. The relationship between Cp, Cv and R is the difference between the Cp and Cv. And what is gamma? So gamma is a very important parameter which is known as the ratio of specific heat. What gamma says? Gamma is the ratio of specific heats. That is, gamma is given by Cp by Cv. Okay? So inevitably, if you get the values of Cp and Cv, you will automatically calculate R and gamma. So I need the values of Cp, Cv, R and gamma both for air as well as for water. So this is your assignment. Okay. I may ask any individual in the next class, he must have those values with him. Okay. And even the definitions of Cp and Cv. What is Cp and what is Cv? Specific heat at constant pressure, specific heat at constant volume. Okay. So keep this in mind. We shall move further. So I was discussing what are the specific properties here. So specific properties are nothing but, let me define you a new property, which is H. What is H? H is defined as enthalpy. Again, what is enthalpy? Enthalpy is nothing but the total heat content of a body. Okay, this you will come across in the second law of thermodynamics. Okay, where H is enthalpy. And what is enthalpy? Enthalpy is total heat content of the body. How much heat capacity does a body have? So that particular description is been validated using this property. Okay. Now, capital H is enthalpy, and small h is specific enthalpy. So what is the difference between the capital H and small h? So I can convert enthalpy into a specific enthalpy just by dividing mass. I mean to say, the small h is equal to capital H divided by m. Got the thing? So, see, small h is what? It is specific enthalpy. Okay, that is equal to enthalpy divided by its mass. To generalize this particular statement, any specific property can be calculated by its property divided by mass. To form a conclusion, specific properties are those properties which are expressed per unit mass basis. Okay, so whichever the property, it might be anything, it might be entropy, it might be a pressure, it might be a volume, okay, it might be anything, but if that particular parameter is expressed per kg, then it becomes a specific property. Okay, so just to have the hold on these concepts, we shall discuss some of the more examples. So capital V is your volume. Okay, now I need specific volume. So what do I must do? Niharika, what should I do now to get the value of specific volume? Yes. So I must divide the volume with its mass. Then I will get the specific volume. Okay. And capital S is entropy. Okay. So I want now specific entropy. Okay. So specific entropy is represented by small s here. What should I do to get my specific entropy, Shabat?
Divided by the mass, sir.
So you have to divide by the mass. So capital S, that is entropy divided by mass, will give you the specific entropy. Similar to your pressure. So pressure is indicated by capital P. Okay. So if I want the specific pressure, then what should I do? I should divide P divided by the mass. Then you will get the specific pressure. Hope these concepts are clear. So just remember, specific properties are just calculated for a specified amount of mass, a specified amount of area to get a specific property. Okay, you can take the notes for the whole thing: intensive property, extensive property, and the specific property. Okay, and just intimate me once it is done. Meanwhile, I'll be marking your attendance. Okay, just I'll be calling your name since there are more people here. Just answer if you're there. Okay, Abdul Rahman.
Present, sir.
Abhinav.
Yes, sir.
So you're marked absent, man. Begin to respond when I call. Huh?
When, sir?
Yes. Okay, reply in the chat box. I'll talk to you. Okay.
Okay.
Reply in the chat box. Adarsh.
Present, sir.
How should I call this? 05. 17MD05. Okay. Next is Ahmad Reza.
Yes, sir.
Ahmad Reza. This is your first class?
Yes, sir. This is the first class.
Okay. Have you introduced to me in your first class? Have you given your introduction?
No, sir.
Then tell your name and which place do you belong and what you want to do after your graduation.
Sir, my name is Reza. I'm from Kerala.
Okay.
I'm planning for further studies.
Okay. So further studies in which field?
I was planning MBA.
You're planning MBA. That's great, man. All the best for that. He's not. And Abhinav, when I called you, you did not respond. That is the reason I have marked you absent. Okay.
Oh, when, sir?
In the start of the session.
The start, I was having a heavy rain, so I couldn't hear what you said, sir. So I was changed my
Okay,
place.
Abhinav. Considered. Okay, considered. I have marked you present. Okay, from next time, please to respond.
Okay.
Akshay. Okay. Amit S. Lahari.
Present, sir.
Okay. Amrit.
Present, sir.
Okay. Next is Anvit, Ashwin, Ashwita, Chandan C,
Present, sir.
Chandan C. So this is your first class.
Yes, sir.
So introduce yourself. Let me know about you.
I've introduced already, sir. Anyways, my name is Chandan.
Okay, you were present on the first day,
Yes,
but
sir.
because of fees issue, okay, got it. Okay, anyways, no issue. This was that.
Present, sir.
Okay. Fahad.
Present, sir.
Okay. Faizan.
Present, sir.
Next is Gaurav.
Present, sir.
Next, Gautam. Gautam. Okay, Jabil.
Present, sir.
Karthik M.
Yes, sir.
Mohammed Fazil.
Present, sir.
Mohammed Shihab. I have not seen present. Okay, fine. Mohammed Tausif. Muwaz. Muwaz. Okay, then Suraj.
Present, sir.
Nafa Abdul Rahman.
Present, sir.
Okay. Mitanar. Okay. Next is Nadesh. Nadesh. Okay. Next, Niharika.
Present, sir.
Nishchit.
Present, sir.
Nitin George.
Present, sir.
Nishchit is present.
Yes, sir. Present.
You attended on the first class, which was introduction class.
Yes, sir.
Okay. Nitin.
Yeah, present, sir.
Have you attended?
Yeah, first class I attended.
Okay. Omkar Mahesh Patel. Patil, sorry. Omkar. Okay. Prarthana.
Present, sir.
Okay. Next is Patish. Patish. Okay. Prajat.
Present, sir.
Prajat.
Present, sir.
So you were also in the first class.
So first class I
Introductory
attended,
class
sir.
attended?
Yes, sir.
Okay. Rakshan.
Present,
Rakshan.
sir. Present, sir.
Okay. Ramdas.
Yes, sir.
Given your introduction already.
Not yet, sir. I'm from Bangalore and
Okay.
I'm planning to do higher studies, sir. I'm interested in machine learning.
Okay. Machine learning subject. That's great. So where do you find that?
Sorry, sir.
I mean to say, where exactly, which university offers that course for you?
I haven't researched about it yet, but I'm quite interested in machine learning. I'm ready to go abroad to study.
Okay. There are few very limited universities which offer that particular course. Okay.
Yeah,
Um,
yeah.
Update me once you join. Okay. Even
Yes,
I
sir.
am interested in that. That's great.
Yeah.
Ramdas. Next, Ranjit. Ranjit. Shabit.
Present, sir.
Okay. Saga.
Present, sir.
Shehzad.
Present, sir.
Next is Shashank. Shashank. Okay. So have you completed, guys? Shall we move further?
Yes, sir.
No, sir. Wait a minute.
Okay. Shashank BC. Shashank BC. Shetty Sujay Jairam. Shetty Tejas Devraj.
Present, sir.
Shramat Kumar. Okay.
Present, sir.
Tejas Shetty. Okay. You are present. Okay. So this is your first class or you attended the first one?
No, sir. I attended the first class.
Okay. Sriraj.
Present, sir.
Sriraj. Yes, man. Same question.
Present,
First
present,
class?
sir. No, sir. Second class.
Yeah, got it. Okay, fine.
Yes.
Saurabha.
Present, sir.
Saurabha. Sumant.
Present, sir.
So, guys, if I've not taken your introduction, please take the chance of speaking and introducing yourself, okay? So, since there are many new students coming up in this class. Sumant. Sumant. Okay. Varun. Vigneshwara. Amit Sangoli. Nilesh.
Present, sir.
Okay. Prajwal Hegade. Prajwal Hegade. Sandesh. Rachan. Rohan. Varun. Adarsh. Sampreet. And Muhammad Amin.
Present, sir.
Who is this? Muhammad Amin.
Yes, sir.
So first class?
No, sir. I was there in first class. First class.
Okay. Yes. Hope it is done. It has been long. Okay.
Yes,
Shall
sir.
we move?
Yes, sir.
Okay. So I have explained to you what is a pressure. Pressure is nothing but your force per unit area. Correct? So what are the different units of pressure you know, man?
Bar.
Bar. So exactly what is 1 bar? So pressure is nothing but force per unit area. Force is measured in newtons and area is being measured in meter square. So definitely 1 Pascal, which is the basic unit of the pressure, is nothing but 1 Newton per meter square. Am I correct?
Yes, sir.
So what is 1 bar? What is 1 bar?
10 power 5 pascals.
Exactly. So it is 10 to the power of 5 pascals. What is the significance of 1 bar? Why only 10 power 5? Why it cannot be 10 power 6 or 10 power 7, something other than that? What is the significance of this 10 power 5? Anyone?
Atmospheric pressure.
Exactly. So 1 bar is always equal to the atmospheric pressure, which is equals to 1.013 into 10 to the power of 5 newtons per meter square or pascals. So that is why 1 bar is equals to 10 to the power of 5 pascals. That's great. Any other units of pressure you know apart from bar? Have you studied fluid mechanics or turbo machinery, any of the subjects previously? In your previous semester?
Yes, sir.
So which one? Both the things
FM.
or?
FM,
So
sir.
FM you
Fluid
have studied.
mechanics.
So fluid mechanics, if you have studied, there is a concept of water column in that, correct? The concept of water column, what does it say? If there is a water column like this, okay, and this is its height, and this water column is being connected to a pipe like this, okay, which is flowing. So this is a pipe where it is flowing in this direction. Now, there's a water column connected to this particular pipe. It rises through a height of h like this. So from this, only from this data, I can calculate what is the pressure through which the water is flowing in the pipe. How?
Rho G.
Exactly. Who is this? Rho GH. Who said that?
Purple.
Prarthan. That's great, man. So pressure in this pipe can be just calculated by the formula rho GH. That means there is a relationship between the water column height as well as your pressure. So that also can be used to express your pressure. Even the height of the water column can also be used to express your pressure. That is what I say. So pressure can be calculated. The pressure which the fluid is just flowing inside the pipe can be calculated as in rho GH, and rho being the density of this particular liquid. The density of this liquid is rho. Okay, that is how you can just relate the height of the water column. Not only necessarily be the height of the water column, it can even be sometimes the mercury column also. Okay, even if the pipe is flowing with the mercury, and if it rises by a height of h, so then also you can calculate pressure by rho g h, where density of the mercury is around 13,000. Okay, and density of water is around 1,000. Okay, these are the few of the data I just want to give you. Okay, and what is 1 bar in terms of water column? And what is 1 bar in terms of mercury column? Anyone knows this? Hope you got the idea of what is water column and what is mercury column. So what is 1 bar in terms of water column? So how much height it has to raise to indicate 1 bar? That is my question basically. Similarly, when it comes for the mercury also. Any idea, guys? Okay, so 1 bar of in terms of water column is 10 meters of water column. So if the water is being raised to 10 meters, then it is equal to 1 bar of the pressure. Similarly, in terms of, you can just calculate the things by using this relation here. Okay, you know the pressure, which is 10 to the power of 5 Newton per meter square, which is 1 bar. That is equal to density of the things, 1,000 and 13,000 for respective water and mercury. The value of G, so you know the value of density, so you can easily calculate what is the height of the water column to read 1 bar. So when you calculate that in terms of water column, you get it as 10 meters. And in terms of mercury column, you'll get it as around 76, I guess, 76 centimeters in and around. Centimeters, okay? So these are the few descriptions of the pressure and all. You can just take it, the notes for it. Yes, 76 centimeters of mercury. Okay? Even you can take the specific volume also here. Okay? See, density and specific volume are reciprocating in nature. I mean to say, what is specific volume? It is volume by mass. Is it? Volume per unit mass is your specific volume. And what is your density? It is mass by volume. So if you observe this equation 1 and if you observe this equation 2, definitely your specific volume is a reciprocal of the density. Correct? So that already I have written here. So, okay. Already I have written here, so you can just take that. Okay. Complete the notes up till here. Just 2 definitions and 3 of the equations.
Hello, sir.
Yes.
Sir,
Yes,
about my attendance.
Amit, this one.
Yes,
So where were you when I called your name?
call.
Listen to class, man. Okay. Have you taken your notes?
Taking,
Writing
sir.
it now? Okay.
Yes.
So I guess it will be done by this time. Shall we continue?
1 minute.
Okay, take your time. Shall we move then? So until this particular point of time of the class, whatever we have discussed are just the basics of the thermodynamics. I mean to say, we have all discussed various properties, various units of those, okay, types of the properties, basic definitions like what is a system, surrounding, control surface and all. So the foundation stage to learn the thermodynamics has been already laid. Now what you are entering into, from now on whatever we discuss is completely the study of thermodynamics. Okay, thermodynamics are exceptionally related to different processes. I don't know how many of you have heard it: isobaric, isochoric, isothermal, adiabatic, polytropic, and the different sets of processes which happen in a system. So now by this time we have understood what is a system and all, isn't it? In that particular system, what are the different processes that occur? That point we'll be discussing now. So it is very important just focus. Okay. I will take an example of a pressure cooker again. So there is a pressure cooker and we will be heating up this. Okay. So for this pressure cooker here, okay, so I have different types of instruments attached. I mean to say, I have attached a thermometer inside a pressure cooker to measure the temperature. Okay, and even I have attached a gauge, necessarily a pressure gauge, to measure the pressure. I have made sufficient arrangements inside since this one is a fixed volume, but if the system is of not fixed volume, I will place some of the instruments which can measure even the volume. Okay. Initially, there is no heat provided to the system. Okay. So after I start to give heat to the system like this, what happens? What happens to PVDs? I mean to say, what happens to pressure? What happens to volume? And what happens to temperature? Any guess?
Pressure increases, temperature increases.
Volume decreases.
Volume decreases, fine. So there are few of the observations. So many of you say pressure would increase and temperature would increase and the volume would decrease, is it? And in order to understand the movement of this system, so where is my system basically? The system is here, right? So this is my system here. So understand how the system is behaving, okay, with respect to time. So if I go on increasing the heat energy, I've given the heat input to the system, if I go on increasing it, how the pressure changes, how the volume changes, how the temperature changes, we must come to know. We must be able to visually understand it. For that process, we have different diagrams. That is PB, TS, okay, even PT. Okay, many of the diagrams are there. After all the diagrams, the most important being the pressure versus volume plot. Okay. Okay. Now, Using this system, I'll be expressing how the pressure is being varied. So according to you, the volume is changing or not changing in a pressure cooker. If I filled completely, okay, if I fill the water completely in a pressure cooker without leaving an inch of it, then I start to heat, whether the volume will change or not change. If I take an example of a IC engine here, okay, if I take an example of IC engine like this, okay, and the control volume is being this, okay, initially when the piston starts to reciprocate, what happens, the control volume will get increased when the piston reciprocates, is it? So here, definitely, there is a change in volume, which was V1 and the V2. So the volume has changed from V1 to V2, and the difference in the volume, we can just get it as V2 minus V1. So there is a change in the volume when it comes for an IC engine. I want you to answer whether there is same change in volume when it comes to a pressure cooker like this. Yes, Gaurav. So what do you think? The volume would change in a pressure cooker? Gaurav B. Panjan. Okay. Okay. Next, Fahad.
Volume decreases, sir. Not sure.
Not sure, but you think volume might decrease. Okay. Chandan C. Chandan C.
The volume might decrease, sir.
Volume might decrease. Karthikeyan.
I think volume will increase.
Volume would increase. This is Nashad. Nashad.
Yes, sir.
Yes, man. So what do you think? Volume can increase or decrease? Or it remains the same thing? It is unaffected by things.
Sorry, sir, I didn't hear you.
Okay. Is there any problem with my audio again?
Sir, actually, your question was not clear, sir. There is a voice breakage.
Okay. Okay. Now it is clear.
Yes, sir.
Yes,
Yes, sir.
Okay. So Nashad, I asked you in IC engine. I have clearly stated you in this particular space here that the volume will definitely increase or decrease. It might change from V1 to V2 or V2 to V1 when the piston reciprocates. So definitely there is a change of volume when it comes for an IC engine. But for a pressure cooker, which I have been explaining initially, okay, whether the volume will change.
no, sir. Volume might not change
Why, Nishad? Why do you feel so?
because it will be like closed and steam will be
Correct.
there inside.
Correct. So there might be a chances of transformation of its phase. Phase, I mean to say, it might transfer from water to the steam phase, is it? The water can just transfer its phase, but the overall volume remains same, according to you. Prarthan Jain.
Yes,
Yes.
Yes, Prarthan. So according to you, what is your verdict about this?
Volume changes. Decrease.
Volume decreases according to you. Yes, Prajat Rai.
So the volume doesn't change, sir.
Volume
It
doesn't
remains
change.
same.
Remains the same. Niharika.
Yes, sir.
So what is your view on this?
The volume remains constant, sir.
Volume remains constant. Okay, fine. Reza.
Yes, sir.
So what's your view?
So I also think the volume will remain same.
Exactly, guys. So the volume will remain same. There might be the change in the transformation of its phase. Okay, the phase may get changed from liquid to vapor or it can increase its temperature also for an instant, okay? Because you are supplying heat, isn't it? Naturally, the temperature will increase. Yes, definitely you are giving the heat input, the pressure also might increase, but your total volume of the system remains the same thing, okay? So if the volume remains the same thing, I mean, volume is not changing, and pressure, naturally, I think everyone will agree that the pressure would increase for an instant. When you just start to give the heat to the system, what happens? Your pressure naturally, this is it. So that is the thing, basic sense. Now, so if I want to plot this particular process on the PV diagram, so what I will be doing is, I will just plot it like this. Is that right? Can you analyze the things using the PV diagram? The volume is unaffected, is it? The volume is unaffected. Whenever there is a change of time, there is the same volume being there, which is the volume of your pressure cooker, okay? But what happens to its pressure? The pressure is being raised from here to here when you are supplying the heat. So this particular PV diagram, which I will just, this particular PV diagram will exactly represent the process of it, yes or no?
Yes, sir.
So this is how you will analyze the thermodynamic process. Now I will call this particular process to be isochoric process. So this is one of the process where the volumes remain same. If the volume of the system remains same throughout the process, then that particular system or that particular process is being termed as the isochoric. Got the point? Now, there are different processes. There is like, there are totally 5 processes. I'll just give you a brief it out and we shall produce for the next class, okay? So first process is being isobaric in nature. What is an isobaric process? Isobaric process is something where your pressure remains constant. So if your pressure remains constant on the PV diagram, how does it look like? It is just a horizontal line where the pressure is constant here. Volume will goes on increasing, that is a different story. But isobaric process can be represented as such. Second thing is your isochoric process, where we have just discussed about this process, where your volume remains constant, is it? So if your volume remains constant, your PV diagram will look like this, correct? A vertical line where the volume is constant for the initial stage as well as for the final stage, and your pressure goes on increasing. So that is your isochoric process. Number 3 is your isothermal process, where your temperature remains constant. So if the temperature remains constant, the plot of the PV diagram would be observed as a parabolic in nature like this. So it both pressure as well as the volume changes. We shall look into it very detailedly in the further coming classes. Okay, that is your isothermal process. Number 4 is your adiabatic process. Adiabatic processes. In this particular process, what happens? We shall discuss what is an adiabatic process. It resembles in shape the way the isothermal process is being executed, but there is a little bit of difference in it. Okay, we shall discuss in the next class. The 5th one is the polytropic process. The polytropic process also remains the same thing as that of the isothermal and adiabatic process, but there is a difference. What is that? We shall be discussing in the next class. So I have clearly stated you what is isobaric process, what is isochoric process, and what is isothermal process, where the pressure, volumes, and temperature naturally remains constant respectively. But when it comes for an adiabatic process, there is something which remains constant. Okay, and how we will be discussing in the next class. And even the polytropic process also. See, the isothermal, adiabatic, and the polytropic process, all the 3 processes resemble same in the PV diagram, but they have been identified with a specified distinction. What is that distinction? We will be understanding in the next class. Hope you are clear with the concepts of different processes as of now, which one I've just told you, there are 5 basic processes. You have to remember this for all the other classes, which forms the basics for all the other classes, which is isobaric, isochoric, isothermal, adiabatic, and polytropic. Okay, so we shall be discussing in detail. So in the next coming classes. Okay, where I was. Thermodynamic state, and we shall discuss in the next class. No issue. Okay. Any other doubts, guys? So on the things which you have discussed today.
Oh, sir.
Everything was clear?
Yes, sir.
Okay,
Yes, sir.
sure.
Yes, sir.
Okay, man. So we shall end up the class now. Have a great time and have a great day.
Thank you, sir.
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 Okay. Was the video and audio not clear, Niharika? Are you there? Okay.